Okay, so before we look at this writing an expression as a single logarithm, there's a couple properties of logarithms we need to know. They're actually corollaries of properties that you already know about exponents. And so one is if you have multiplication inside, if you split it up into two separate logarithms, it's addition. So that's the same as like when you're multiplying two things, you add the exponents, since the answers from a logarithm are actually exponents. And if you have division, it's the same as subtraction. And then one other little interesting one, if you have an exponent inside of a logarithm, you can pull it out front as multiplication. That's a similar rule to when you have an exponent to an exponent, you multiply them. All right, so then when they give you problems like this one, you get to use all of those rules in conjunction with each other. And it doesn't matter on these what the base is. All that matters is that the base matches. You can't combine ones that aren't the same base. But they won't try to trick you and do that to you or anything. All right, so things we can do. Anytime we have a number multiplied out front, we can bring it inside as an exponent. And then this is dealer's choice. You can write x to the 1/2, or x to the 1/2 is the same thing as the square root of x. So however you choose to write that should be totally fine. And so this one, the 2 can come in, so it's w squared. This one doesn't have a front number. You can treat the front number like -1, or we can just use our rule that subtraction is the same as division. So notice if we go to combine these two terms would be multiplied by each other. And this term would be divided since it's subtraction. If you want, once you get used to these, you can do that all at once. So log base c of square root of x times w squared all over z. All right, so we can try another one. I was trying to find an example that looked a little different than this one. There are some that they throw some parentheses on. And good news on that, you can distribute it in there ahead of time, or you can combine logarithms. It doesn't make a difference which one you do first because you're going to get the same answer. So some people like to distribute this first, or some people like to treat these ones like division. It doesn't matter which one you do. So this is 3 times log base c of z minus 6 log base c of x plus, and then we can start bringing in exponents. So anything that's multiplied out front, if we bring it inside, it's an exponent. So this is z to the 3rd minus, and once again, you can bring it in as -6, which negative exponents mean the reciprocal, so it would end up on the bottom anyways. But usually I'd say people are more used to doing this, and then remembering that subtraction is the same as division when we combine them into one logarithm. And so now we can combine them all into one. Log base c of this one and this one are multiplied, and the x to the 6th is divided because that's the only one that's minus. So that's what they're looking for in that topic, just combining them into one logarithm.